Example 4, as we finish up this lesson. A square is inscribed in a circle. Write the area of the square as a function of the radius r of the circle. Okay, so we're still trying to model functions using from formulas. Okay, now I'm trying to remember. Okay, a square is inscribed in a circle. Which way are we drawing this picture?
Circle and then a square inside.
Okay. Now I'm trying to remember which way do I draw it better. Do I draw the circle better?
Yeah.
There's my circle. My square never ends up quite great, but.
Oh, I'm stupid. I drew the rectangle. Stupefied.
Okay, we're going with that's close enough.
I have an idea.
I have an idea as well. If his
I have an
idea's
idea.
wrong.
I don't. I tried to say that.
I drew another
Okay.
rectangle. It's like as well.
The length is
Oh.
the length is r minus x, and the width is also r minus x.
No.
Because x would be like the
Well,
distance.
no, it would be.
Okay.
It would. Dang it. Okay, so
Okay.
r is the radius, and the radius is half the circle, right?
Yes.
So it's some.
Can I draw a couple of dimensions in here that might help?
Please. Yes.
Okay. So, r is radius, yes?
Mhm.
What's the r do?
From the middle to the side,
Middle to the side. Now,
Or the middle to the top,
Or
or
top.
top to the bottom.
middle to
aside.
the side, the circle somewhere, yes?
Yes.
Now, the ideal place to draw it in this scenario is to a corner.
Oh.
Okay, now I'm going to call this length r because it is the radius of the circle, yes?
Hold on.
Now, the other piece that we can talk about,
Diameter.
so we're trying to keep in mind, we're trying to write area of the square. It's as a function of r. Let me pause you for a moment and ask you, how do you do area of a square? Length times width, but what do you know about length and width?
They're equal. So
They're equal. So what you often hear is s squared, as in s standing for the side of a square. So I'm going to start off my formula as side squared. So what's that mean over here? Each side of the square is s. Okay. Now, if I give you one more hint here, I'm going to draw another radius in.
Radii. Oh.
I'm going to draw that radius in. Because here's the deal. You guys know that you have to use the radius.
Okay.
And somehow there has to be a connection between the side of the square and the length of the radius, right? There's that connection that we have to, because we don't want s in here, we want r. So how do s and r connect?
because s would be equal to r to the fourth power. Or no. Because it'd be like r squared plus r squared. So it's like, I don't know.
Okay,
2r squared.
okay. Inform everyone of where your brain's going with that.
Pythagorean theorem.
Okay.
A squared plus b squared equals d squared.
Do you guys see? I drew this triangle in here because there is a right triangle we can use. The formula we often think of is a squared plus b squared equals c squared. In this case, a and b are the r's, the two pieces that meet at a right angle,
So just be r squared plus r squared because s squared is.
equal to s squared. So
It's just r squared plus r squared.
what is r squared plus r squared?
R.
2r squared.
No.
2r
Two r
squared.
squared.
2r squared. 1r squared plus 1r squared is 2r squared.
I bet you.
Okay.
What love?
Now,
Oh yeah.
with this in mind, and actually I'm going to reverse it.
I bet you. You too little.
Ideally, in a normal situation, I'm trying to do what? I'm trying to solve for s to put it in place of r. Now, Logan saw the shortcut here in that, what do we just find right here?
S.
S squared. What do we need to replace up here?
S squared.
S squared. So could you just go straight to it and say a is
2r.
2r squared?
You could.
Yes.
Very well.
And that's perfectly fine. Now, what would we normally do if it wasn't that connection? We would solve this for S, right? And if you solve this for S, relevant in this scenario, but in the general idea of problems, it can be
Solve
good to
for
know.
S, it would be the square root of S over 2.
No,
I thought you solved for R.
no.
Solving for S.
Oh, just square root of 2 R squared, so it'd really just be the square root of 2 R. Like square root of 2 and then or R. Yeah.
I'm going to write my R out front. Okay, so if we're trying to solve for S so that we have something to plug in, because here's my thing. It works this time, and I am all for what Logan said, that we can just take S squared equals 2R squared and plug it in. I'm not going to argue that. However, if that doesn't work in another situation, you solve for S, right? Take the square root of S squared, you get S. The square root of 2R squared, well, the square root of R squared becomes R times the square root of 2. The idea here, S is R square root of 2. What can we do? You can plug that in. And so S squared means I'm going to do R square root of 2 and square it when I fill in what S is. When you square that, though, what do we end up with? When you square R, you are at R squared. When you square the square root of 2, you end up with 2R squared. Okay? As we mentioned, I am all for it. I agree that you could have just caught it right there and used that. I'm just going with the scenario of what if you couldn't have done that. Fair enough?
Yes.
I don't think Logan much likes it right now, but that's all right.
I think I got the next one.
Questions on example 4 before I move on anywhere. The key to a problem like this is drawing a picture and looking for connections. Okay? What is the connection between the length of the side of the square and the radius of the circle? Okay. Example 5 then if we're ready.
Why is it asking for two numbers in the answer?
Okay. A number added to 4 times that number is 450. What are the two numbers? Okay, so there's two numbers we're talking about. A number, and it's added to 4 times that number. So I want to know the number, and I want to know 4 times the number, basically.
Oh,
Okay.
you want 4 times the number.
Yeah.
90 and 360.
Yeah, I agree.
Because 90 times 4 is 360. 360 plus 90 is 450.
Basically, how you solve it, you set 450 equal to x plus 4x, and then you
Okay.
get 450 equals 5x to divide.
Okay, so I do need to, not disagree with the answers, but again, it's modeling with formulas, modeling with functions. How can we set up an equation that will solve this scenario and will solve all of them? And exactly, you went to the calculator and started messing around with numbers, didn't you?
Yeah.
I want us to have an equation that will work. So, a number. What can we use for a number?
X.
X. Added to.
Plus
4 times that number
4x.
4x.
is
450 equals 450.
equals 450. 450.
Which I essentially
So-
did that just without the whole
Okay.
equation.
So the idea here, though, is that, yeah, the shortcut is going to be take 450 and divide it into 5 pieces because you need the original number plus 4 times that number. So if we actually solve the equation here, x plus 4x is
5x.
5x. If 5x equals 450, then we find out that x is
90.
90. That is your number. It also wanted 4 times that number. So 4x is going to be 4 times 90, or in other words,
360.
360. Okay? Okay. Homework. You're going to see some similar, you're going to see some differences. what I've tried to do is give you some examples to help you think through some of these, okay? Go through the homework. We will talk over questions tomorrow of ones where we need to think through it a little bit more, okay? And on that note, you have work time. Note, none of this says evens, does it?
No,
Okay.
all even. Only even.
1 through 16 all, 18, 19, 21, 22, 23.
Okay, well,